Welcome to the Tips for Manufacturing video training for Mastercam, covering 3D high-speed toolpaths and surface machining. We're going to start off with a surface machining overview, just to get you acquainted with the variety of toolpath styles. People often ask me, how do I know what toolpath to use? And really, variety is the key. You need to become acquainted with your choices. See your part as a group of patterns. Look at the sample files that come with Mastercam. Most people don't install them. They're the best way to learn about the new features in Mastercam. And a great thing is, you can copy those sample operations into your part and then just reselect the surfaces and see how that toolpath works on your part. So to find these toolpaths, we go to Toolpaths, Surface High Speed, and this is really broken up into two areas. First, we're going to talk about the roughing. Now, rough cuts remove the bulk of your stock. Core roughing leaves a boss or a core standing up. It cuts from the outside to the inside. Area roughing is a cavity or pocket type milling. Rest roughing mills the remaining stock. It gets the rest of the material. OptiCore. It's like core, but it's optimized for machining efficiency. And OptiArea, well, it's like area, but optimized for machining efficiency. OptiRest, same thing. The next area is for surface finishing. Now, finishing cuts will smooth and blend the part. And the first one is the waterline machining. This is a Z-level contouring. It's best used for walls that are nearly vertical. Scallop is for flat or nearly flat areas, and you have complete control of the scallop height. Horizontal areas. Well, they are for flat horizontal areas. They only do flat areas. Raster makes parallel cuts across the surfaces. You control the angle of the cuts. Pencil is for tracing out or cleaning the areas between surfaces. Spiral is excellent for dome-shaped parts or areas. It creates a great-looking tool pattern on the part. Radial is a spoke-shaped toolpath. Think of it like the spokes in a wheel. It cuts from a center hub out. Hybrid is a combination of toolpaths. Think of it as being scallop for doing the tops and waterline for doing the walls. And then we have project. And a lot of people will say project, but that's because the English language can be pretty messed up sometimes. So this is project, as in projecting a 2D toolpath onto a 3D surface, or as a film projector would project an image onto a screen. So let's talk about these roughing options. Well, roughing has two basic categories. You have your cavity, pocket, area roughing, and then you have your core and boss roughing. So that would be where you're leaving something standing, as opposed to cutting a cavity. So with the core or boss roughing toolpaths, we can pick either core rough, or we could pick OptiCore rough. And we also have OptiRest for getting out the rest of the stock in some of the nooks and crannies. Then we have cavity, pocket, or area roughing toolpaths. And for those, we have area clearance, and then we have OptiArea rough. And of course, OptiRest, because OptiRest will work whether it's a cavity or a core. For the finishing toolpaths, we have high-speed waterline, which is a Z-level machining. So it's a waterline contour cut. It cuts from top to bottom or from bottom to top, and it's best used for nearly vertical walls. It also gives you very good boundary controls. Then we have the scallop toolpath. Scallop gives you cusp control. You control the height of the scallop. It has equally spaced cuts and gives a very improved surface finish. It's best for free-flowing surfaces and tops of surface areas. Horizontal area will face off all the flat areas on the part. You get an equal cut spacing, and it has very good boundary control. This is raster. You might also refer to this as parallel. It's an equal space cutting. It works on a grid or a parallel line cutting. You control the cut direction. It has high-speed transition capability, and you have boundary control. Pencil traces the intersections. It's used to clean the corners between surfaces. Spiral creates a scroll face type of a cut. It's a continuous cutting motion based on an equal spacing. So you specify a minimum start radius and a maximum end radius, and you can also use boundary controls with this. Radial is a spoke wheel style of cut. It uses equally spaced angular cuts, and you define the center hub, and it also has very good boundary control. Now this is project. So in this case, the example is they're projecting that V8 logo down onto the surface of the part and using that to create the toolpath. So this drapes 2D paths over 3D surfaces, and it's not limited by surface directions. You can engrave basic curves onto a surface. But another one is the surface finish blend. This is actually in a different category of toolpaths. So this has some flow line capabilities. You drive the direction controlled by your curves. So the curves that you select to define the profile is what helps the toolpath to flow in the direction of the cavity. It's not a real HST toolpath, but a very powerful tool. So you'll find that under Toolpaths, Surface Finish, Blend. So the key is to visualize your toolpath. Look at your part, think about how it flows, and after seeing these toolpath options, you should have a better idea which ones will fit the geometry of your part.